Hi everyone, I'm Whitney from Pine Tree Programming. We're thrilled to partner with you this year as we dive into coding with microbits. Before we jump into the tech, I want to set the stage. Our role isn't to present ourselves as computer scientists with all the answers. It's to work alongside you as educators, helping you use this tool effectively with your students. We're here to support you every step of the way. You don't need to be a computer whiz to lead a strong computer science lesson. What matters more is modeling curiosity, problem solving, and persistence. When students see us testing ideas, troubleshooting, and thinking out loud, they gain the confidence to do the same. Today is about exploring possibilities, building comfort with the tool, and leaving with strategies you can actually use. So, why this specific device? Well, think of the microbit as a pocket-sized entry point into physical computing. Unlike coding on a screen where everything is virtual, this allows students to see their instructions come to life in the physical world. It's a bridge between logic and creativity. It senses light, feels motion, and gives students a tangible win within minutes of plugging it in. Let's take a quick tour of the hardware. We've designed this overview with a teacher's perspective in mind, focusing on what your students will ask about and what you'll need to troubleshoot. Let's start with the LED grid. This is your primary output. It's a 25 light display, and it's the best place to start with students because they can immediately see their name or a simple emoji scroll across the screen. Next, we have buttons A and B. These are the most intuitive inputs. In your lesson, you can frame these as cause and effect. If I press A, then the microbit does X. It's the foundation of all programming logic. On the back, you'll find the processor and the pins. The processor is essentially the brain. These gold teeth, or the pins, at the bottom are used for expansion. Eventually, your students can use alligator clips to turn things like headphones or even a banana into a touch sensor. It's a great way to incorporate makerspace elements into your coding time. When we're coding, we always start with the USB cable. The USB does two jobs at once. It powers the microbit and it lets us send our code from the computer onto the device. That's why I want everyone to plug in with the USB first. It's the most reliable way to see if your code actually works. If something isn't working when you're plugged in with the USB, that tells us the issue is probably the code and not the power. The battery pack comes later. The battery only gives power. It doesn't send code. So your program has to already be flashed before you unplug. Battery packs are great for projects that move or travel, but they can run out of power or get loose, which makes debugging harder. So remember this rule. USB is for building and debugging, but batteries are for showing off and exploring.
So now that we've seen what the microbit looks like and we've identified the different parts of it, let's dive into the lesson students are going to be exploring this week. Students will need to access the Microsoft Microbit website. The link is on this screen. It's a good idea to figure out how you want students to access this lesson before you get started with them. Ideas might include creating a QR code for students to scan. If you have Google Classroom, you may want to consider posting the link in the Google Classroom, or if students have iPads, you may want to use Apple Classroom to push the link out to student devices. Once students land at this website, we encourage them to bookmark it so it's easy for them to find if the window closes or if they need to return to it. Let's take a look at what the website looks like once we've arrived there. After they've viewed the lesson, you'll want them to click on the blocks, Start Tutorial. This is the type of coding that they'll be doing today. Python and JavaScript are also other types of coding, but blocks is a great entry point for students just learning to code. Once they click on blocks, this page will show up, walking them through what they can expect to learn from this activity. See your name in lights. Code the microbit to scroll your name across the screen. If you have students who need directions or instructions read aloud to them, this website has an immersive reader that students can launch simply by clicking on this symbol wherever they see that. After students have read what they're going to be doing today, they can click on OK. This is the student's dashboard for their activity. Over on the left-hand side, students will see an example of the microbit that they're coding. They can make it larger by clicking on this. Once students have coded something, it will start simulating across here. To stop it, students can click on the stop button. To refresh it or restart it, students can click on the arrows. If students have coded sound in their microbit, they can choose to mute the audio or play the audio by clicking on this icon. Students can also take a screenshot by clicking on the camera icon, and students can exit or enter full screen mode by clicking on this icon. Directions for what students should expect to do are at the top. Again, they can find their immersive reader here if needed. The toolbox is where students will find basic tools or code blocks that they'll be asked to build with. As students progress, this toolbox will fill with more and more types of block code. And finally, over on the right-hand side, students will find their building space. This is where they'll be able to drag and drop code to create different coding commands. If students make a mistake, there's an undo arrow down in the lower right-hand corner. And if they undo it too many times, they can redo. If students need to make this space larger, they can with the plus sign, or if they need to see it smaller, they can click on the minus sign. Students can manipulate how they see this code by dragging these along the right side and the lower right side. This is especially helpful as students progress and create more complex code. After you navigate through to this page and give students a brief guide of where they can find certain things, you'll want to encourage students to start the activity. Click on the basic category in the toolbox. Drag a show string block into the forever block. Then in the show string block, change the text from hello to your name. So students will need to click on basic and drag this show string into the forever. According to the directions, they'll need to double click on that and type their name in. Students can click on the play button to see their name in lights on the microbit. This simulator, again, will show what their microbits will look like once they plug in and download the code onto their microbits. After students have finished this step, they can click on Next. And the directions are, look at the microbit simulator on the screen. Do you see your name scrolling across? Great job. You've turned the microbit into a digital name tag. Students can click on Next again. If you have a microbit device, connect it to your computer and click the Download button. Follow the instructions to transfer your code onto the microbit and watch your name appear in lights.